This is a test track I designed. It has 2 power supplies, 4 power distribution modules. Basically, I can plug in whatever module I design. It has plus minus 5 volt, plus minus 12, plus minus 15 volt available. So these are the modules I've done up till now. And I want to focus on the CB module. So you can see everything is off right now. What happens on power up? These start up and they go into sleep mode. So I can wake him up by pressing the rotary encoder. Get a little splash screen in the menu. And here I have my selection of CB radio models. At the moment I have 23 models programmed into it, or 23 different configurations programmed into it. What's on the screen now, the first is the Midland, the old style Cybernet chassis. So I can hook up 4-pin, 5-pin, 6-pin, GX16 aviation connectors, or a 5-pin DIN connector. So depending on the model. With the rotary encoder I can just step through the different models that are in there. And I can see the pin out and also the function of the pins. So M means microphone, TX obviously transmit, RX receive, SC is a combined shield and common. Just looking another one. Okay, so here we have another example of a 5-pin which has microphone, a shield for the microphone separate from the common which is used for RX and TX. So that's common with president microphones that have a 5-pin. So let's get back to the first one. So I can just go through and see the models that they are used in. I can add models. For now I think I get most of them covered. So it shows me the type of connector. So this is the 5-pin DIN, this is the 6-pin. A question mark means that the function is undefined. It can be anything, well, undefined but still testing. So it can be an up or down button, for example. Let's get back here, the first one. So obviously I can just press the microphone and test to see if the RX and TX changes. So you can see an LED on the screen that's green. It can also be orange or red, depending on the impedance. So I'm not only doing a go-no-go test, I'm also measuring the resistance. So if it's too high, I get either orange or red, depending on the value. If it's below 20 ohms, I get a green. If it's between, let's say, 20 and 100 ohms, I get orange, and above that I get red, which means there's still some kind of switch action going on, but it's not optimal. It can be that there's corrosion on the switches or on the connector itself. So I want to test for that. I just don't want to have a go-no-go test. I want to know what's going on. Pushing this encoder, I can toggle the mode, and now I can see the actual measurements. So I can see I have 2 ohms here, infinite here. So I push the button, it changes 2 ohms here, infinite there. So this way I can have a look at the actual connection. I'm testing the connection here, testing the wire, testing the switches, all at the same time. So this is the ohms measurement. A third function, press it again, is an oscilloscope. So if I press now, I can test the modulation. So that's testing of the modulation. I have a pot meter here, so I can adjust the gain of the modulation. In case I have a preamplified microphone, I can reduce it. So these are the basic functions. I also have an output here for monitoring the audio from the microphone. The plan is to have an extra module here with a signal tracer, so I can listen to what is going on in the microphone, listen for cracks. I can also see cracks and everything on the scope display as well. So you can see some noise going on there. That's from the switching. So that's the basic function in RX mode. So I have the 4 connectors for microphones. There's also a transmit mode. If I press long enough, I get a menu. I can put this module back to sleep, or I can go to the TX mode. In TX mode, I'm only using this connector, which is also a 5-pin DIN, so I can wire it up, make some adapters for any radio I want to test. And I have the pin out here and the functions that I'm using. So I have a common for the RX-TX, mic and shield. So what I can do here, if I press the TX button, the relay switches and I'm transmitting. I can also change the modulation, none, 1 kHz, 500 Hz, 2.4 kHz, 2.5 kHz, and a dual tone for SSB 500 plus 2.4. So that is used when I press the TX button. So this is useful to test radios with a fixed modulation. I can reduce the modulation again with this pot meter. It's a dual pot meter. One is used for the microphone gain and one is used for the output signal. So this is a bit beyond the basic go no-go testers that are on the market. There's one feature I might add or could add, and that's an automatic or guided determination of the paint functions. But I have basically 23 models are already in there, so I think I got it pretty well covered for now. So I can always add modules. That's it. Gonna talk a bit more about how it works internally next. A little bit on how it works. This is an ESP32 module. The CB connectors are over here, connected here, 6 pins maximum. All the pins are protected by the special diodes here. The way we measure, we have 2 measurement systems. One is resistance measurement between any of the pins and ground, and the other is the sampling of the audio from the microphone. So 2 measurement systems. Now the measurement system for resistance is based on this thing here, multifunction tester, well described on the net. And what it does, we have these resistors here, a port expander. Now any of the pins can be pulled down to ground by the port expander. It can be pulled up to 5 volt via a resistor, or it can be floating. The way the measurements work, the common pin or combined shield and common pin is grounded. The pin we want to measure, for example the transmit pin, is pulled up via a resistor, and then we measure the voltage across the pin, so between pin and ground basically. Now the problem with the ESP32 is that the analog digital converter is not very good. It cannot measure below 150 millivolts, and on the top end there's it's not very linear. So the solution is to have external analog digital converters. I'm using ADS1115 modules. Each of them have 4 channels. So I have 8 channels in total. 6 I use to measure the pins, 1 I use to measure the ground reference, and 1 I use to measure the 5-volt reference. So these are measuring the voltages. Now by measuring the voltage over the pin, the voltage drop over the pull-up resistor can be calculated and the resistance can be calculated. So that's all done in the ESP. So why do we measure the resistance? Because an older microphone can have contamination, oxidation on the connectors on the switches as well. So there might still be some contact, but not optimal contact. So we want to measure the impedance rather than just a go, no-go testing. So that's the part of the resistance measurements, pull-up resistors, port expander, and log channels. For the part of the modulation measurement, we have a multiplexer here, which multiplexes one of the pins to an amplifier. Now, as I said, the analog digital converter is not that good. Not in the low end, not in the high end. But in the middle it's fine, we can use that. So it cannot measure a negative signal anyway. So what we do is, with this op-amp, we not only multiplying it, but also putting it on an offset of about 1.6 volt. So even with no signal on it, there's about 1.6 volt on the input, analog input of the ESP32 analog digital converter port. Now, why multiplication? Well, the signal from a microphone is very low, so we'll have to multiply that by 10, approximately 10, to get a decent signal that we can measure. And there is a potentiometer, so we can adjust the gain. And then the output is sampled at a high speed. A lot of trickery is done inside the ESP32 to get a high speed reading. I think we are doing now 24,000 samples per second. So it's using the DMA sampling over the internal I² S-bus. So that's for the sampling of the audio. Now for the generation of the signal for the testing, the transmitter mode of the tester, we're using the digital to analog converters of the ESP, which are also not that great because they're not very controllable, the range is limited and so on. And those we mix up and not amplify, but attenuate. Also in this op-amp, it's a dual op-amp. So the output, again, the dual pot meter 1/2 is used to reduce the amplitude of the output signal. So relay is controlling the RX, TX functions. So all these connections go to this connector here, a 5-pin DIN, so I can hook up basically any adapter jig I can make to fit the CB radio I want to test. So I can do 500 Hz, 1 kHz, 2.4 kHz, 2.5 kHz, and also a dual tone for SSB adjustment, 2.4 and 500. So that's all done by the ESP32. So that's basically it. This part here runs on 5 volt, ESP runs on 3.3 volts. So we have some level shifters in here that will take care of that. So that's a bit on the basic of the electronics.